Let's go ahead and have an overview on colligative properties. And this is where we're actually really starting to focus on that physical behavior of our solutions. So what we'll see is, in general, our solutions behave very similarly to pure solvents. There might be slight deviations in their behavior, but for instance, salt water will behave very similarly to water. There will be slight exceptions here and there, and maybe you'll have a higher or a boiling point or a lower freezing point. But what we're going to see is we can actually predict those changes using colligative properties. And colligative just means that all of these properties are bound together. So we're going to relate all of these properties in the coming lectures together. So for instance, we talked about salt water. Well, pure water has a melting point or a freezing point of 0 degrees Celsius and a boiling point of 100 degrees Celsius. Now, if we have a 1 molal, you'll want to note that this is molality, not molarity. If we have a 1 molal solution of sodium chloride, now the freezing point is decreased to negative 3.8 degrees Celsius, and the boiling point is increased to 101 degrees Celsius. So as we go on, we're going to explore this relationship. So whenever we talk about the colligative properties, again, we are comparing the pure solvent to that of the solution, but here are the 4 properties that we're going to look at. We're going to be looking at the vapor pressure, so we'll start to focus on Raoult's law. We'll see that the boiling point of the solution is higher, so we call this boiling point elevation. The freezing or the melting point of the solution is lower, so we call that freezing point depression. And then finally, we'll see that the solution will actually have osmosis. And so we're going to be looking at the osmotic pressure, which we use a capital Pi to denote. So in the coming lectures, we're going to look at a mathematical relationship of Raoult's law. We're going to group together the boiling point and freezing point depression, and then we'll also look at the osmotic pressure.